Hello, Math 1 students. This lesson's on 4C, which is identifying and naming angles. The better you understand how to identify and name angles, the easier geometry gets, right? Because angles is a huge part of multiple facets of geometry. So we're going to start with just defining an angle. An angle is a figure which is formed when two rays, or the key here is they'd be lines, that intersect at a common point called the vertex. So when I look at this angle on the side, right, the arms, which is labeled here, right, this arm or side, this arm or side, if you notice, they both are rays that share that endpoint there, which is called the vertex, right? So this shared endpoint is the vertex of the angle. And what's created here is the angle inside. So it's basically like, what is the alligator eating? The alligator eats, right? If I look, the alligator eats the angle, all right? And these angles are measured in degrees. And the degree symbol is the little circle in the upper right-hand corner of the numerical value in the future. Now, the symbol for an angle is just this symbol here. It's just a little angle symbol. And that's key when we go to name these angles. So the vertex again of the angle is a point where the two rays or lines intersect, right? So in this case, the vertex would be B. Okay. Now, we can name these angles many different ways, right? One way, and the most common way, is using 3 points with the angle symbol. And here's the thing, the key here, and I'm going to just put this in parentheses, is the vertex must be in the middle of the name. Oh. Okay, that's key here. So when I go to name this using 3 points, it's almost like, and I always tell students, like, the easiest way to do it is how would I trace the angle without going over a side twice or lifting the pen? So if I looked, I'd have to start at A or C. When I trace it, I start at A, I'd have to go to B, then I'd have to go to C. So I can name this angle A, B, C, or I can actually go the other way. I can start at C, go to B, and go to A, and that would be angle CBA. So when we use 3 points, you have to understand the vertex must be in the middle. Now, if the only angle at that vertex, right, if there's only one angle at that vertex, we can just use, right, you can use the vertex. But again, that's only when there is one angle at the vertex. So in this case, I can name it angle B. Now the third way, right, which is tough to do in this example here, but the third way, you'll see a number without a degree symbol. Right? So if I put like a little 1 in here, and the numbers are usually less than 1, but if I put a little 1 in there, right, there's no degree symbol on it, so we could just name it angle 1. Okay? So those are the 3 common ways to name an angle. So looking at the first couple of examples here, identify the vertex of each angle and name each angle 4 different ways, right? So right away, example A, the vertex of this angle would be Q, right? That's where both rays meet. Now, one way I can name it, I'm just going to start with that numerical value, angle 4. Okay, if they give you that numerical value, that's the easiest way to do it. Another way, right, is to just use the vertex, angle Q. If I had to use 3 points, I would name it angle P. If I trace it, remember, I trace it P to Q to R. Or I can name it angle RQP. But again, notice the vertex is in the middle. So the next one, right? The vertex for the next example, right? If you want to pause the video and come back and check your answer, right? That'd be great. So the vertex of this would be W. One name would be angle 3. Another way to name it would be angle W. But if I name it using 3 points, I either start at V or X. So I can go angle VWX or angle XWV. Right? So those are many different ways, right, that I can name this angle. Now in this diagram, if you look, there are 3 angles. Here's one angle, here's 2 angles, then here's 3 angles. So if I were to name the red angle, right, I cannot use the vertex for this for the simple reason, if I say angle, if I just say angle S, are you talking about that angle, or the whole angle? Therefore, you cannot use the vertex to name any of these angles. So to name the red angle, if I trace it, angle PSQ. So angle PSQ. Or, again, I could do angle QSP. Vertex has to be in the middle. If I name the blue angle, I'm going to trace it, right? Angle QSR here. Angle QSR. Or, if I start at R, SQ. And finally, when I look at this green angle, okay, the green angle starts at P, goes to S, and then R. So that'd be angle PSR, or I could start at R, go to S, and then P. Okay, so that's the 3 angles that are in this diagram. So now next, if I take angle JMK, that's this red angle here. If I take that angle and I add angle LMK, if you notice here, how when I trace it, right, I trace it in the order they give me, then I put an arc in what the alligator is eating. It's eating that angle there. If I take the red and the blue and I combine them, right, what I get here is, if I combine them, I go from here all the way to here now, right? And that angle would be angle JML. So this would equal angle JML. You guys remember, the angle symbol is critical to include anytime you name an angle. All right? So that leads into like the next step when we do angle addition for the next learning target. So here, if we took angle 3 is this angle here, right? Right here. It's that angle there. That's angle 3. Angle 4 now, right, is this here. So when I look at angle 4, that's that there, which is this angle here. If I add those two together, it gives me this big angle here. And there, I have to name it using the 3 letters. P to Q to R. Angle PQR. Or I could say angle RQP. Either one of those would be fine. Next, what happens now if we look to subtract? Such as, if I have angle DAB, angle DAB, that's the big angle there. Then what happens if I go ahead and I subtract angle 8, which is this angle here? If I take this big angle and I subtract, right, this angle, what angle do I have left? Well, what didn't I color in? I didn't cover in angle 7, which could also be named angle DAC or angle CAD. So if I look, this is the angle that I have remaining. Okay, so that again plays a role when we get to the next learning target. So for this example, right, when we look, angle 2 plus angle 3, if I take angle 2 and angle 3, and I put an arc in those two angles, what two sides do they touch? They touch this ray and this ray. So I know this is the angle that's getting eaten. How would I name that angle? Well, if I trace it, I would start at R, so angle R, then I'd go down to P, then I'd go up to T, angle RPT. Okay, next. And again, before we go to the next one, notice how helpful it is when you mark the diagrams. When I look at angle 3 to angle 4 to angle 5, when I add those three angles together, the alligator eats those, which, if I trace the lines those arcs touch, or rays I should say, these are the rays that are touched. And that's the big angle that gets eaten, right? So if I had to name this big angle here, that'd be angle SPV. Or, again, I can start at V, go to P, and then S. So angle VPS. Now last, if I take angle QPU, and again, guys, trace it, angle Q to P to U. If I subtract, right, angle 2 and angle 3, and I'm going to say I'm going to add in here, subtract angle 4 also, right, because it doesn't make sense to do the other one. If I subtract angle 4 also, if I subtract these three angles, what angle did I not shade in? I did not shade angle 1 in, so angle 1 is what I have remaining. So this would be angle 1, or you can name it angle QPR, or angle RPQ. Okay, so know the difference of when to add and when to subtract. Now there are 4 types of angles that we need to be aware of, right? You guys have all seen these since junior high. The first one is a right angle. A right angle is exactly 90 degrees. And you see 90-degree angles or right angles all the time everywhere you go, right? Any wall and floor create a 90-degree angle. So here, this box, anytime you see this box, tells you that angle is 90 degrees and a right angle. Now a straight angle, if I have an angle where I put an arc in it and it goes from one point on the line to the other point, that's a straight angle. And straight angles are exactly 180 degrees. Okay? Now, the reason I showed those two first is to get an idea where 90 degree is. So this would be 0 degrees, right? And when I go 0 degrees all the way around to 180 degrees, right? That gives you an idea of an acute angle, right? If you look, if this is 0 degrees, you know 90 degrees would be here. So an acute angle, right, is greater than 0 degrees, but it's less than 90 degrees. So it's between 0 and 90 degrees. An obtuse angle, if you look, right, if this is 0 degrees, here's 90 degrees, you can tell that that angle is more than 90 degrees. So an obtuse angle, right, we say in this case, it's greater than 90 degrees, but less than 180. If it was smaller than 90, it'd be an acute angle. So we start at 90 degrees here, right? So we start at 90 and we go all the way to 180 degrees. So here, when we look, if we had to classify these angles right, obtuse, straight, or acute, right away, this one looks less than 90, so this would be an acute angle. This gives you a straight angle, right, which is 180 degrees. See this little box? That's 90 degrees, so it's a right triangle, or right angle. This is a straight angle. And here, as you can see, that's more than 90, so that would be an obtuse angle. The last example is they give you this crazy diagram and they want you to determine if the following angles are acute, right, obtuse, or straight. So the first angle, FOE, what I like to do is trace them. F to O to E, that angle there. This angle looks less than 90, therefore we would say it's an acute angle. Now, angle GOD is this angle here. If I look at that angle, that's definitely more than 90, so this would be obtuse. Angle FOC, that's this angle here. Again, clearly more than 90 degrees, therefore that would be obtuse. Angle AOC, angle AOE. Angle AOE. If you look, that's a straight line. Anytime you're given a straight line, that is 180 degrees. Next one, angle GOA. If I look here, if this angle is 90 degrees, this angle is 90, this angle is 90, that there is going to be, AOE is a straight angle, right? And GOA would be a right angle. Then when I look, HOC, clearly more than 90, therefore it is obtuse. Okay, now go ahead, do the student practice and let us know what you have questions on.